This is project 2, video number 2, the one in which we write the code. Here's what we had. I'm going to fire up MATLAB. You know how to fire that up by now, or if you don't, take a look at the first project, video number 2. Get that fired up. I'll go edit to open up the editor, and then start writing my code. I got function. I'm gonna say dummy. So this function is not returning anything. All I'm doing is making a graph, so I don't need to have a return variable. And dummy equals, I'm gonna say plot percent energy lost, and it takes no arguments, so I'll just open and close the parentheses there. Type in, take a look back at my paint, my work, pencil and paper work, to see if I've done anything. Okay, no, I didn't say what I was going to name the function. So get in here, I'll tab over, have the contents of the function indented, and I want to make an array. And I'm going to call that, make an array of M1 values. So M1 equals, and then here's a nice function for doing that, linspace which creates an array from the starting value to the ending value. I think we had to go to 10 kilograms in steps, evenly spaced steps, and the number of steps that it's going to have is whatever number you put here. So I got M1 is 100 values running from 0.01 up to 100, up to 10, 0.01 to 10, and there are 100 steps. The idea is to have enough points in there so that the graph looks smooth, even though really it's just a bunch of straight line segments connected together from one point to the next. But for a theory curve, that's the way to go. Just use a lot of points. And then percent M mechanical energy lost, plot percent, I think I'll call that mech E lost. And then I think I actually had a name that I was supposed to call it over here, percent ME lost. Store results in percent ME lost. So as long as that's not what I called my function before, percent ME lost. Let me check and make sure I'm being consistent with what I said I was going to call it, percent ME lost. Yep, that's good. I think I'll call this plot percent ME lost. I believe I was planning on using lowercase there, so yeah, just use lowercase everywhere for that ME lost idea. And then percent ME lost equals get percent ME loss. I think that's what I called my function. I gotta make sure that that's just right. Of M1. So this will actually this is going to have a list of 100 elements stored in 100 different values, and then this, just by putting that list in as the argument of my function, it should calculate it for every value in there. We'll check to see if that works. But then it'll just be plot M1 comma percent ME lost. Okay, I'm going to save that, and it's getting saved under this name. Let's make it so you can see the window I'm working in. Nope, that doesn't work. Plot percent ME lost. That's my .m file. Save, and I'm going to, at this point, I'm going to put a copy of the, let's see where I saved that. So save as, yeah, that's all I got in there, and I put it in my code, in a directory, my code, in project number 2. So I'm going to go ahead and make sure that I get a copy of the function that I wrote for project number 1 in this same directory. So I'm going to pause the video and go ahead and do that. Actually, I think I'll let you watch. So what I'll do is go File, in the editor, this I'm going to cancel out, File, Open. So I'll move this down here where you can see it. File, Open, and then I just have to find where I put project 1, my code, and then I'll go ahead and open that up. I can do that by double clicking on it. So it was %me lost. I was wondering if I had the right name in the new one. But what I really want to do at this point is File, Save As, and then I'll save it where I'm working on project number 2. So project number 2, my code. I'll save that there as well. Alright, then I should be able to close that one. So I'm going to come over here and close it. And I got the other one up. And it is get %me lost, or at least that's what I called it. And get %me lost is the name of the file, and it should be the name of the function as well. Notice this, plot %me lost. Plot %me lost is the name of the .m file as well as the name of the function. So I think I'm actually in a position to try running this. I'm going to go to MATLAB command window and say plot %me lost. Open, close. It actually takes no arguments, and see what happens. So there's something it didn't like in there. Let's scroll up. This is M1, so it did create an array of values that went from 0.01 up to 10, and it's trying to do some divide in there, and doesn't like it. So let me see if I can. I might have to adjust plot %me lost, but I think I know a way of doing it here where I'm going to go array fun of, this gets an @ sign in front of it, comma M1. So let's see if that works any better, and then I'll tell you what's going on with that. So I've saved it. Go over to the MATLAB command window. Try running it again. I just hit the up arrow and run it, and sure enough, I get a plot. This plot, I need to do a lot of work on this plot. I got to title it. I got to put x-axis title with units, y-axis title with units. But I'm going to save that for the documentation and final touches video as far as fixing up the graph. But so far it looks like it's working. And now what I want to do is tell you about just what I did in there. Go to the editor. The idea here is the array fun says use this function. You need an @ sign with this particular one. Array function. Think of it as array function. It says use this function individually on every element that's stored in the array, that list M1. So do them one at a time. So the original way I had it, it was trying to do them all at once when I just said get %me lost with the single argument m1, and that didn't work. But if I tell it do it element by element by using array_fun and then the same function and the same argument list, it does it one by one, and that worked. So it created an array that %me lost with all those values that represent what my function get %me lost returned for each and every value of m1. Alright, I'm printing too much stuff out to the screen, way too much. So I got to put semicolons on the end of these. This one doesn't really print anything, so that semicolon is superfluous, but I'll put it there just for the heck of it. Maybe make it look a little more consistent. And then this time it just runs the function, it creates the graph, but and let's make sure it really did create the graph, and I'm not just opening up it again. That time I close it. Yep, it creates the graph, but it prints nothing to the screen. Absolutely nothing in this case, because it's not even a function that returns something. Just does the graph. So this actually represents the conclusion of video number 2 for project number 2.